Alright, today we are talking about algebra, one of the branches of mathematics, and this contains all the rules that we need to do in operations in mathematics. So today we shall be looking at indices, and we know that indices, when we talk about indices, we mean powers or numbers with powers. For example, this number here, x power n, this is an index. The singular form of indices is index. So we shall look at how we can handle indices when we find them anywhere. Okay, so we shall start by looking at the laws of indices. Here we have 5 major laws, but there are many other laws. So we start with law number 1 that talks about multiplication. Consider as multiplication, we have two indices. We have x to power n and then x to power m. Okay, but we are multiplying those two indices. Note we have the bases the same. Maybe before we continue, an index has two parts. We have what we call the base, and then we have what we call the power. So x is the base here, and then n is the power in this case. So if we go back to our number 1, and you're multiplying two indices with the same base, xx, but different powers, we have n and m. We say that what you do, we can simplify this by saying, let me consider only one base, because the bases are the same. Take x, then what do you do to the powers? Do add them. Alright, so we are going to look at an example in that case. For example, if you have 2 times 2 to power 2, these are two indices. We have 2 to power 1 and then 2 to power 2. We are saying that these ones we are multiplying two indices, and they have the same base but different powers. So what we do, we said consider the common base, which is a 2, and then add the powers. So I'll have 1 plus a 2, right, which is equal to 2 to power 3. Okay, and this one is actually, everyone can press their calculator, and we know that we shall get 8. Okay, this is done. I want to look at the other thing that students look at, and they forget some rules, or they interchange. Please, this one in red is not true. If you have x to power n, okay, plus x to power m, this one is not right. It is not equal to x to power n times m. Please, this is not right. This is not right. This is not right. Never think about it. Whenever you think about it, just know it is wrong. When you find such a case, what you have to do is just place your calculator and you get what you need. Indices only work in this case when we have multiplication. Okay, this side you multiply into indices, but you're not adding. When you add into indices, what you have to do is just press your calculator, you get what you need. Alright, let's proceed to law 2. Law 2 talks about division of two indices. We have x power n, we have x to power m. The base is the same like before, but we are now dividing. What do we do to the powers this side? You take the common base like here, but this case we subtract the powers. Alright, let's go on and look at an example. So let's look at this example. If I have, for example, 5 to power 4, yes, and then I'm dividing it by 5, power 2. Okay, this one we said get the common base, which is 5, and then subtract the powers. So we have 4 minus a2. Alright, someone there, get your calculator. This one is 5 to power 2, which you can get as 25. Alright, I'll also note, or you note also that don't interchange. In any case, if you have this in red here, minus x to power m, this one is not equal. I repeat, it's not equal to x to power n divided by m. Please note this as well. That is not true. Don't ever be tempted to think about this. Okay, let's look at law number 3. And number 3, we're talking about such a case. You have an index, okay, in brackets, and then there is a power outside it. So how would we work out that? How would you simplify it? We are saying that if you have this, then what we do, we can always put in this outside power inside. And in this case, we multiply. It means we multiply these two powers, n and m. So it becomes x to power m times n, or n times m. And actually, writing this has no problem. I can always maybe choose, depending on the need, to take n out and then bring m in, depending on when and what you want to use it for. So either way, if either you find this or this, it is all equal to this. Yeah, let's look at an example here of example 3. If you have, for example, I have a 10, right, and then this 10 is squared, and then it is powered by a 6. In this case, our n is 2 and our m is 6. We are saying that this one is the same as 10 to power. Multiply the powers, the inside power and the outside power, so that you end up with 10 to power 12. Okay, and now I'm saying that this answer would be the same if we add 10 to power 6. Now the 6 inside, then this one powered by 2. Okay, if you have this or this, the working is the same. What we do, just multiply this outside, the powers, the inside power with the outside power, and then it will give you this. Okay, so like I said, you can always, there may be need to interchange from this to this, or from this to this, or from this to this, or from this to this, depending, as we shall see in more examples to come. Okay, and we look at 4. This 4 is quite easy. Like if you have any number like x and you power it with a 0, okay, it always goes to a 1. Okay, always remember, it is not equal to 0. Please note, it is not equal to 0. All right, this one is not correct. Don't say that x power 0 is 0. This one is wrong. All right, so for example, if you have let me use a 2 to power 0, this one is always equal to, this one is equal to a 1, not 0. I repeat, not 0. Okay, We only get 0 if we multiply 0 by any other thing. So, for example, another one, even if you have 1 million, okay, even if you have 1,000,000 or 1,000 and you power it with a 0, this one will always go to a 1. Okay, let's look at number 5. Number 5, you're talking about the rational indices. Okay, you have a base, and then the power is rational. It is a fraction. Okay, a fraction. So what does it mean when you have such? It means they want you to get the nth root of this base here. Okay, the nth root of the base. So in this case, they want us to get the nth root of x. When I mean by what do I mean by the nth root? This number n can be 2. Like maybe if you add x to power 1/2. So it means in this case our n is 2, and then they want us to get the square root of x. Okay, x can be anything. This n also can be anything. It can be a 3, and if it is a 3, then it means they want you to get the cube root of x. Let's look at an example. If you have a number like 8, and this 8 is powered by 1/3. So we are saying that this one requires, because our n in this case is 3, then this one needs the cube root of 3. Sorry, of 8. 8, cube root of 8. Okay, so what is the cube root of 8? It is a 2. You may place your calculator. Maybe if you have 4 to power half, this one is equal to the square root. They want us to get the square root of 4. What's the square root of 4? A 2. You may also include maybe plus or minus, because the square root always gives you 2 answers, a plus or minus. Yes, thank you for watching. For more questions and examples, please check in the description. There is a link to the questions. Just click on the link and then you'll be directed to where the questions are. You may download and try out. Don't forget to subscribe and watching these videos and sharing them to all your friends. Okay, goodbye.